select some more difficult facts. It is 2008 June, question number 5 part B. 2008 June, question number 5 part B. State 5 responsibilities of the visitor's location register in R99 code. I said I will find the answer for it, sir. But I could not during the break. I had a lot of things. Can you give me 5 minutes? I'll find it. You also want to be there, right? So, okay. We'll learn it. Okay, give me a few minutes, I'll find it. Amplify is actually inside the transmitter. When we say one of the transmitter, looking around looking. එහෙමත් පුළුවන්. ට්‍රාන්ස්මිටර් එකක් තිබෙලා පොලරයිසින් මැටීරියල් එකක් දාලා වෙන් කරන්නත් පුළුවන්. අර සාමාන්‍යයෙන් මේක තමයි පොලරයිසේෂන් එකට යන්නේ. So regarding polarization diversity, the diagram when you draw polarization diversity, I think I have not given a diagram, but just had a little note. If you ask to draw a diagram, it is similar to frequency diversity. That means you have signal coming into a splitter, then transmitter A, transmitter B, then transmitter A is sending frequency with horizontal polarization, B same frequency with vertical polarization. Then they combine, go to the answer. Diagram wise it is same as frequency diversity, except that in frequency diversity there were two frequencies, F1, F2. But here same frequency but two polarized. But diagram is the same. Diagram is the same. Remember that. Okay? Amplifier in the sense, when you say transmitter, in your box when you say transmitter, the amplifier is inside there. You don't need to separate it from amplifier. Why do you want amplifier? Yeah, we have two signals, same frequency but opposite polarization. Amplifier will be inside the transmitter. You don't need to show separately the amplifier. When we say TXA, TXB, the TX means it has the amplifier inside. Don't get it. No, it is one antenna. Dual polarization antennas are like this. You find difference with lines like this. For vertical polarization, lines like this for horizontal polarization. If you have a antenna like this with vertical width and horizontal width, both we call it width pack. Width pack antennas are for dual polarization. It can handle vertical as well as horizontal on the same antenna.
Sir,
if it is a full dish, it is ideal, but most of the time the full dish is not used because of the wind loading. When you put the full dish, it is taking a lot of wind force to the tower, so you need a very strong tower. So a lot of operators use the width pack where the wind will go through. The force on the tower is much less. But effectively the full dish is the best. Effectively full dish is the best.
So full dish pattern implement karana best.
Full dish has everything. Full dish can handle any polarization. Circular, vertical, horizontal, everything can be handled by full dish. You don't need pattern. Patterns are needed if you are not using the full disk. See?
But even we could have two antennas.
Yes, receiving
We can have one
if you like, the receiving antennas can be combined.
like
Yeah, or you can have two antennas. If you have antenna like this, that antenna is only for vertical pole. If you have antenna like this, that one is only for horizontal pole. So you can have two dishes, one for horizontal, one for vertical, then combine the block diagram wise there is no difference.
or we can have optical combiner
Then grid pack.
with that can combine
Yeah,
and
you can combine the signals and put a grid pack if you want, or you can separate them and put these two separate, two ends.
then other side we can
Other side also you can have two separate antennas if you want. If you want to separate antennas, put them like this. Put them like this. This goes to one receiver, this goes to other receiver. If you want to combine an antenna, you can put the grid pack and then split the vertical and horizontal polarization into two receivers. Both are possible. Up to you to select. Give me 5 minutes to find the answer for the HLR and GLR.
Dale gift gaya Dale gift gaya ini kan diagram කරන්නේ ඔව් අනිවාර්යෙන් කියනවා diagram නැතිලා මේක විතර තියෙන්නේ මට ඔළුවට ආවේ අර ඇන්ටනා එක දැන් මෙහෙම ඇන්ටනාස් මම දැකලා තියෙනවා ඔය ඒක දැකලා තියෙනවා මොකද හේතුව ඒක අන්ලෝඩින් එකයි අර විදිහේ පැටර්න් එක එකම ස්පෙસિෆිකලි තෝරගන්න කැන්ඩලා වගේ ඔය රටාවක් තියෙනවා ඒක Electrolyte ෆෝන් එක තියෙනවා BTS දෙකක් කරා යන සිග්නල් එක RBC එකේදී මෙයාගේ අප්ලින්ක් වෙන පැන් කම්බයිනින් ඒදී එයාගේ ට්‍රාන්ස්මිෂන් එකෙන් එන සිග්නල් එක මේ දෙක හරහා ඇවිල්ලා මෙතනදී කම්බයින් මේ ඇබිලිටි එක ඕනේ හෑන්ඩ් ඕවර් ප්‍රොසීජර් එකට මොකද දන්නවද ඒ කියන්නේ හෑන්ඩ් ඕවර් වලදී එකකින් එකකට කනෙක්ට් වෙනකොට දෙකේම කනෙක්ට් වෙලා ඉන්න සිටුේෂන් එකක් එනවා. අන්න ඒක නිසා ඒක ඉම්පෝටන්ට් කියලා කියනවා. ඒක ලොකු ගානක කියන ප්‍රශ්නයක් ඒකයි. ඒකම මොකක්ද නැහැ. ඒක නේද? ඔක්කොම ඕනේ අර අයිඩියා එකේ ඉන්නවා. ඕක තියෙන හෑන්ඩ් ඕවර් ප්‍රොසීජර් එකේ. මේක හෑන්ඩ් ඕවර් ප්‍රොසීජර් එකේ. ඒක අර කැවිලා ඒකත් හෑන්ඩ් ඕවර් වෙනවා වුණාට ඒක මෙතොඩයිසින් ටෙක්නික් එකත් එක්ක යන්නේ. ඒකත් එක්ක ඩිස්කස්. මේක තනිකර හෑන්ඩ් ඕවර් ප්‍රොසීජර් එකක්. टॉप स्टैंड ओवर वලදී කරන්නේ මේ වැඩ. टॉप स्टैंड ओवर වලදී කියන්නේ බ්‍රේක් වෙන්නේ නැහැ. ඉන්න බේස් ස්ටේෂන් එකේ බ්‍රේක් කරලා නෙමෙයි අනිත් එකට කනෙක්ට් වෙන්නේ. ඒක තමයි. So we'll write down the answer to that. VLR and HLR have very similar functions. So maybe not in the same year they have worked, because they are almost similar if they are in the same year. Maybe one of them they will ask. You can write functions of R99 HLR. Functions of R99 HLR. First add one sentence describing what it is. After that we will write 1, 2, 3, 4. You can write the HLR is the place. HLR is the place where all the subscriber information is stored permanently. It's a non-fixed location that keeps subscriber specific non-fixed location that keeps subscriber specific routing information. Then main function number 1, subscriber data handling. Number 2, subscriber service handling. 3, subscriber statistics handling. 4, mobility management. 5, subscriber security handling. So those are the 5 functions of HLR. VLR also are very similar. So they will not ask in the same year. On a new line you can write VLR. First 2 sentences we will write introducing it. You can write VLR keeps subscriber related information as long as the mobile subscriber visits the area.
Mobile subscriber visits the area. Underline, mobile subscriber visits the area. HLR is always permanent. Earlier we said permanent, but it's not permanent. Right? These records are not permanent. These records are not permanent. They are taken from HLR. When subscriber registers. To the network by power up, that means you start your mobile by power up or by roaming. So there are two ways to register to the VLR, when you roam or when you just power up. Two ways that the records are taken from the HLR. But after he leaves or power down, it is updated to the HLR. Right? When the user leaves the area or power down, VLR updates the HLR. VLR updates the HLR with its last information. Last known information. Then main function. And that number one, active subscriber data handling. Comma, for the area. Only for that area, right? For the area. Number two, active subscriber service handling for the area. Number three, active subscriber statistics collection from the area. Number five, active subscriber mobility management within the area. Last one, security management. While subscriber remains in the service area. You will notice that the five functions are same, except that for the VLR the word area should come and also the word active should come. Other than that, the five functions are same for both. If you ask to give the difference between 2G HLR VLR and 3G HLR VLR, what is the difference? Last one, security management. Security management is heavily improved in the 3G. Other things are almost same as GS. So highlight the last one, security management. That is improved area compared to 2G. So those are the answers for that particular. Other question 5 at about the noise. There is total noise power at the output of an amplifier is minus 10 dB, which is the output power minus 10. Input signal noise ratio is 40 dB. Input signal level is 0 dB. So our full argument is calculate the noise factor for an amplifier gain of 20 dB. First of all, you can mark all this in a paper diagram. After we will see, we need the input signal noise ratio and output signal noise ratio. Input signal noise ratio they have given. Output signal level we can find. Output noise level they have given. What is output signal level? 20 dBm. 0 dBm plus 20. Therefore, 0 plus 20 will give us 20 dBm output signal power. Output noise power minus 10 dBm. So, what is the output signal noise ratio? 20 minus 10, 30 dB. 30 dB. Input signal noise ratio is 4. The two values are now known, 40 dB and 30 dB. At the input it will be 40 dB. At the output it is 30 dB. Then you can calculate the noise figure. Noise figure is 40 minus 30. 10 dB. The noise factor means 10 to the power 10 over 10. That answer is also 10. Noise factor means without dB, noise figure means with dB. Okay? So both answers are 10. So very straightforward one. Meaning of the noise factor. Definition you can give, meaning of the noise factor.
So receivers
If they ask meaning of the noise factor, actually the meaning of it is to account for the internal noise generated by the amplifier. It is trying to identify how good the amplifier noise performance is. You can write it as it's a measurement for identifying the noise performance of an amplifier. That is the best way. It is a measurement for identifying noise performance of an amplifier. Need not be an amplifier, noise performance of a circuit module. It could be an attenuator. It is a measurement designed to evaluate the noise performance of the circuit module. Evaluate noise performance of the circuit module. And then after that you can write the definition. After you write it in words, then you can write the definition. Capital F is SNRI divided by SNR out. And then mention that if SNR is high, that means, if noise factor is high, that means noise performance is poor. SNR low, noise performance is good. Not SNR, noise figure. Noise figure low means noise performance is good. So interpret like this. This is a tricky question because they are not directly asking the definition.
3 marks.
3 marks because only a person with clear thinking will give a correct answer. Other people will write the definition. So if you just wrote the definition, maybe they will not give 3 marks. They might give you something like 2. But if you have mentioned why, what is it trying to achieve, like it is to evaluate the noise performance of the device, maybe you can get full 3 marks. So I suspected they are trying to get that your full understanding of why the noise figure is necessary.
So මේ question එකේදී මේ අර input amplifier එකේ short circuit කියලා කියවම මේක ගන්න මේ කියන්නේ අර input noise එක 0 කියලා නේ ගන්න. internal noise එක හොයාගන්න නේ.
Internal noise එක හොයාගන්න. There is another question about noise in 1 year, which is 2007 June, same paper. 2007 June, question 4. Question 4. Shall we directly compare the answers? Then you can see. Question 4, part B1, what is the answer you have got? Output question now. You can compare, then if they are different only we will try, right? Otherwise, you get 87.8. 87.8. Okay? You got a difference. He has got 28.24. Anyone who got 28.2? What did you get? Different one? 100? 100? That means we have to do that. So, we'll do that question. I think all have got different answers. And some have got no answers, and that will be a problem, right? Some may not have tried it thinking that okay, it's a typical noise figure. Then I will try it at the exam directly. Some people do that. Okay. Part B1, output signal noise ratio. You can again mark the things on the amplifier. Draw an amplifier as a triangle. Capital G is 15. You can mark that on top of that. Then N naught is 7.5 into 10 to the power minus 14. That's also given. That is when input terminals are short circuit. Right? With input short circuit. When the short circuit is removed and a signal of minus 80 dBm is applied, the output noise power rises to new value. N naught now is 22.5 into 10 to the power minus 14 watts. Then we have to calculate the output signal noise ratio in dB. Then input noise power in dBm. Then noise figure in dB. So when the input is short circuited, why do we get the noise at the output? Internal noise. So I think they have given this short circuit idea for you to calculate the internal noise. Okay. So therefore, when you are calculating the signal to noise ratio output, you have to get that internal noise and the noise even with when the signal is present. So when the signal is present, the situation is like this. Minus 80. 2007. Now is
the gain is normal value, not decibel value. 15 is normal value.
15 is normal. Output noise power is known. this output signal power we have to find. That will be 15 times. Going to this time amount 15 times 10 to the power minus 8. So minus 80 dBm means when you divide it by 10 it's minus 8. Then take 10 to the power minus 8 multiplied by this. That is signal output power. Take this and take that with the ratio power divided by now. That is the 10 hours of the output. That means the power that by 22.5 is then power 14. That will give us the value. If you convert it to 10 log, you can find dBm value also. Shall we quickly find? First find that answer. How much do we get? Decibel? Yeah. 58.24 dB. 58.2. How many of you have got 58.24 earlier? You got 58. So only one person is passed on that question. It's a serious problem, because not a difficult one, except that they have given the short circuit thing. So as a hint for you to evaluate the internal. Second part they ask input noise power in dBm. Input noise power in dBm. So that you know only the output noise power here. From that we have to subtract previous noise power. So we will have to take output noise, input noise. Output noise power due to the input noise will be this value. It will be this value 22.5 in 10 to the minus. Minus the noise power which should be there when inputs are short circuited. How much is that? 7.5 in 10 to the power minus 14. Minus 7 will be 50. 16. is the output noise power which is resulting from input noise.
It's 15 point. 22.5 minus
Then after that, therefore input noise, and I will be output noise 15 into 10 to the power minus 14 divided by the gain 50. Divide by the gain, then you will get input noise. 15 watts per gain. Then SNR as the input you can calculate that. Signal power already known. 15 into 10 to the power minus 3. This is given in dBm.
dBm.
There's a little problem in my early answer. Sorry about that. Because M naught is given. This is what this is corrected. It should be dBm. What divided by what? This one is milliwatt. But this is dBm. I did not. Minus 80 dBm means 10 to the power minus 8. When you convert dBm back, answer is milliwatt, not watt. Can you correct? Earlier I wrote watt. It should be milliwatt. So this will be milli. So when you are writing in watt, it is another 10 to the power minus 10 will be there. Watt divided by watt. Can you recalculate? It will be slightly different. Early answer minus 30. Minus 28 by. What did you say? Minus 1? Earlier we got 58.3, now 28.3. So this milliwatt will be used here. So this is given in milliwatt. Output they have given in watt, input they have given in milliwatt. So that is the confusion. Right? So please be careful. Then at the input also same problem will be there now. Input is given in milliwatt, so to convert it to watt, further multiply this by 10 to the power minus 30. So this is the input signal. Input noise power is the answer. And that will give you the SNR and the input. And you can get the answer in dB also. So shall we find the value? He has got 28.2. Then second answer, SNR as the input. Minus 9.99 or minus 10 maybe. Can you double check whether it is minus 10 dB? Here again 15 and 15 and 10. 15,000 you convert to 10,000. Find the dp value. $41.76. Sorry, 41.76. First one, that part should be 41.76. Okay, we calculate SNR in. What they are asking is input noise power only. So therefore, we have to give the answer here. This is the additional calculation which is used for the third part. Second part answer is only this. Input noise power only. That will be when you take log of this minus 14. 10 log of that is minus 104 dBW. Then if you write in dBm, it should be minus 110. 30 dB more. 110 dB. Convert dBW to dBm, you will have to add that minus 140 plus 30 dB minus 110 dB. So answer to the second part is this. Answer to the third part will need this SNR as the input. You can calculate it this way. And then get the answer in dB. How much is it? There is no quantity. 10 to the power minus 8 into 15 is not there. 15 is for the output. Input is only this value, signal power. So when you convert this to milliwatt, so watt it will be divided by 10 plus minus 8. Take 10 to the power, this milliwatt, make it watt, and 15. Just 10 to the power 3. When you convert it, it will be 32. It should be 30 dB. Or if you like, you can directly subtract this and that. That's another way. Minus 80 minus 110 will be again 30. This is the other. The answer is 30 dB. Input SNR is 30. Then question asks what is the noise figure. So now you can calculate noise figure. SNRI minus SNR out. So 30 minus 28.3. 30 minus 28.3. How much is that? 1.7. Answer to the third part is 1.7 dB. Okay, so we'll double check the three answers. First one is 28.3 dB. Second one is minus 110 dBm. Third one is 1.7 dB. I think the difficulty in that question will be that they have not given it directly. They have said input is short circuited, output is this much. When input is applied, output is this much. So therefore you have to get the difference at the output. Difference at the output. So output with the input applied is this much. Output with the input short circuited is this much. Get the difference. The difference is the contribution to the output noise from the input. This is the contribution to the output noise from the input. Okay. And then if you divide this by the gain, you get what should have been the input noise. Input noise is not given, you get what should have been the input. Then by taking the ratio with input signal and noise, you can get SN number. Is that clear? So, first of all, you will have to get the difference of the output noise powers they have given in two occasions. One occasion is with signal, other one is without signal. Get the difference. When you get the difference, you get contribution to the output noise due to the input noise. And then divide that by the gain to find what should have been the input noise. That is the argument of our calculation.
මේ ඇම්ප්ලිෆයර්ස් කියලා දාලා තියෙන මොඩුලේෂන් සිග්නල් සෝර්ස් එකයි එතන තියෙන බෑන්ඩ් පාස් එක free amp එක මේක
එක්සන් ගන්න
ඉන්ඩිරෙක්ට් කියලා නෑ ඒක CD ස්ටෝර් එකක් ඉන්නවා
सिंपल की लड़ी लगे हैं
सिंपल को सामान्य
इंडिरेक्ट लेंगे फ्री एम्प्लीफायर नहीं पास दाने में फिल्टर फिल्टर एम्प्लीफायर नहीं पास
तो ये तो मितन मितन देंगे एम्प्लीफायर्स के लिए देंगे अरे मॉड्यूलेशन आप ये अंदर डायग्राम में सोर्स से का है
ये हरी
यार बीपीएस का नहीं बीपीएस एविला फ्री एम्प का
हां हम देंगे इतना पे बीपीएस आई फिल्टर का डाला नहीं ठीक है ना तो मतलब फिल्टर करने में डाला नहीं
तो ये एम्प्लीफाई करा तो फर्स्ट फिल्टर करना है ये
हमारे फिल्टर करना
खाली फिल्टर करना पूरा
तो लेवल सकते हैं सिस्टम में XM modulator, question number 3, 2007 June. Question number 3, 2007 June, they have given a block diagram. It is slightly different from the block diagram I gave in the class. There are similar parts, there are dissimilar parts. They have given AF amplifier as the first box. In our diagrams, we had the source. Signal source and then filter, then pre-amplifier and then Varacta modulator. But in this case, they have not filtered, they have directly indicated AF amplifier. So after amplifying, you have to filter, otherwise noise will come. So filtering has not been done earlier. The question is, can a filter come after the amplifier? It can. You have to filter it from somewhere, either at the input or at the output of the amplifier. But you can't operate without a filter. Filter is a must, so that is why they are giving that. Basically, they are checking your knowledge about that a filter is required. That is what you have to understand. So, if you just cram the block diagram I have given, you may be in trouble because you might not know that a filter is required, although the filter was there in the earlier one. But the correct way to think is that filter is a must for audio before it goes to the modulator. So if they have not used the filter before the amplifier, you must use it after the amplifier. That is what you have to argue. So A must be a filter. A must be a filter. B could be a pre-emphasis. C could be pre-emphasis. Then Varacta modulator. After that, I think it's same as what we did. Variable frequency oscillator. Frequency multiplier is F. Then capital G is RF power amplifier with and the driver, everything inside that here. And also you can mention, because separate antenna tuning unit is not given, you can mention capital G could have driver, RFPA and IATU, antenna tuning unit, everything in one box. Driver, RFPA and ATU. Then C is a crystal oscillator, D is a mixer and the band pass filter. That part is same as our block diagram, isn't it? C is crystal oscillator, D is mixer and the band pass filter.
But in next one, we have only low pass filter.
Normally low pass filter. In the source you normally put low pass filter. Source is normally a low pass filter because high frequencies you want to eliminate before they go into the modulator. So I think there is a danger in cramming the block diagram as it is without understanding why. As you can see from this question, because they have purposely distorted your thinking by saying the first one is the audio answer. So that means they are checking whether you know that a filter is a must. Therefore filter should be required, should be applied there. Normally low pass. If you want to reduce it to 300 to 3400 only, then you have to use a band pass, 300 to 3400. But if they have not mentioned that, a normal audio, it will be a low pass filter with the maximum cut. If they especially mention it is commercial audio, then you have to cut off at the low end also, because below 300 you should not apply. 300 to 3400. If they don't say anything about commercial audio or anything, you can use normal audio where you don't cut off from the low end, you cut off only for the upper end. For example, if you take FM stereo, you don't cut from the low end, you cut only the 15 kHz upper end. But commercial audio, telephone, you cut the low end also from 300.
So මේකේ අර සැටලයිට් වල වින්ද මේ සාමාන්‍ය විදිහට ගියම නැත්නම් වෙනස් වෙනවා විශේෂයෙන් ලෝ නොයිස් රිසීවර් එක ඇන්ටනා එක සැටලයිට් වලට අදාළ වෙන්නේ. ඇඩිෂනල් මොනවා හරි කියන්නේ නැත්නම් සාමාන්‍ය විදිහට ලෝ නොයිස් එක ගන්න.
This is about satellite. Briefly describe each of the following earth station equipment. Number 1, antenna. Number 2, low noise receiver. What are things we have right? About antenna, it has to be a high gain antenna, high directivity antenna. Why? Because satellites transmit low power and earth stations will need high gain in order to receive that signal. So those are the special things you should mention. Other than that, antenna is for the normal purpose. But you better mention it should be high gain and highly directed antenna. And also give typical ones are like most common one is the dish antenna. Then about the feed, dish antenna, in what form do you put into satellite? I think you have seen outside. Maybe you can draw the dish and then the LNA or LNB here and then the wire to the receiver. So you can draw a situation like that. Then low noise receiver, why? Why do we need low noise receiver? Because again the signal power coming is very weak. Even with a large antenna, you don't get a very strong signal. Therefore, if the noise figure of the receiver is poor, what happens to the output SNR? Output signal noise ratio will be very poor, and your demodulator will not be able to demodulate your signal. Therefore, it is important that we use a low noise receiver. That's how you have to ask. And nothing much, it's just the argument according to satellite. Main argument is satellite will transmit low power. We will receive very low power from a satellite. If they ask why do we receive very low power? because of the distance. Two reasons. One is that the distance is very large. Second is that the satellite is battery operated. Therefore, you don't have large amount of power there. Those are the two reasons. So how do we technically say that? We normally say satellite is power limited. Power limit.
මේ ඩයග්‍රෑම් එක මේකත් මෙතන මේ දෙක ඇඩ් කරනවා නේ ඇඩ් කරනකොට කලින් ඉඳන්ම ඇඩ් කරනවා අර වගේ මේ කිරිල්ලක් නේ සෙල් එකට එන්න කලින් ඉඳන්ම ඇඩ් කරනවා ප්‍රදීප් ඩයග්‍රෑම් එක දිනනවා මේකේ වෙනසක් තියෙනවා මෙතන ඉඳන්ම මේ සිග්නල් ස්ට්‍රෙන්ත් දෙක ඇඩ් කරනවා ඒක ප්‍රදීප් ඩයග්‍රෑම් එක වෙනස් ඒක කියන්න අමාරුයි එක්ස්ටෙන්ඩ් කරගෙන යන්න අමාරුයි ප්‍රොසීජර් එක ටෙම්පරේචර් කොතනද ඩිසිෂන් එක ගන්න කියලා එහෙම ප්‍රදීපගේ ටී ඇඩ් ඇවිල්ලා මේ ටී එහෙම ඉන්නේ ඊට පස්සේ ටී ඩ්‍රොප් වෙනකොට මේකේ එහෙම සීමාවක් නැහැ කෙලින්ම මේ හරිය ඉඳන්ම නුකුත් නැතුව කෙලින්ම ඇඩ් කරන් ඇවිල්ලා ස්පෙෂල් දෙකක් දීලා නේද කෙලින්ම ඇඩ් කරනවා මේ මෙතනට බවුන්ඩරි ෆයිල් එකක් නැහැ
මිනිත් දෙක නම් හරි මේක
ඒ ක්වෙස්චන් එකේ වැරද්දක්
තියෙනවා නේද ක්වෙස්චන් එකේ මේ ලයින් එක ඇඳපු දැන අවුලක් තියෙනවා
මෙහි ඉඳන් ඉන්නේ අදුවන්නේ මේ කඩේකට කලින් ඉඳන්
මෙතෙන්ට පස්සේ වෙනවා මෙතෙන්ට පස්සේ වෙනවා ඒක මේක ඇලෙතිදී
ඒ කියන්නේ
මෙතන දැනගන්න විදියක් නැහැ
නේද? ඔය දැන් මේ සෙල් එක මෙහෙම බහගෙන යනවා මේක නැගගෙන යනවා එතකොට දැන් මේ අපර් threshold දැන් මේ දෙකම ඇඩ් කරාම අපර් threshold එකට කියන්නේ වඩා අඩු නම් ඇඩ් කරනවා නේද? මේක දැන් වැඩි වෙලාවක් නම් ඇඩ් කරන්නේ
ඕනේ අඩු නම් ඇඩ් කරනවා නෑ මෙතන මේකට ලයින් කරනවා මෙතන ඒක කියන්න පුළුවන් ඉතින් ඕක මේක එක්ස්ටෙන්ඩ් කරලා කියන්න පුළුවන්
ඒක වෙන සිග්නල් එකක් දැන් මෙතන
ඩිටෙක්ට් කරපු වෙලාව
ඉඳන්
තමයි ඇඩ් කරනවා කියලා මේක හැටියට එක්ස්ප්ලেইন කරනවා නම් එහෙනම් එක්ස්ප්ලেইন threshold එක කියලා එකක් නැහැ ඒක. ඔව්. ඒතර මෙතන තමයි threshold එක. 0 නෙමෙයි. ඒකනේ තියෙන එක. මෙතන 0 නෙමෙයි මෙතන threshold එක. threshold එක ගන්නයි නේද නෑ ඇඩ් කරනවා.
ඒ කියන්නේ මේ graph එක තව මෙහෙට පල්ලෙහාට තියෙනවා
ඒක. Somebody take care of that. We'll look at this one now. This is there's a little trick in that 2005 December. 2005 December question is there is a diagram they have given. From this point onwards, these two are getting added. Remember that this, I think they have given this minimum. Minimum is not 0. Minimum is a threshold. They have not mentioned. So when the threshold is passed by the other signal, it is being added to this signal and you can keep it. What I gave you in the class is, this is not the threshold. We had a 0 bit. That's the difficulty. You have to explain when you are explaining to the examiner that this lower level is the threshold for starting to add. Same as our classroom explanation, but graph has been given only the top area. So interpret it that way, then explanation will be same as what we did. Question number 9 in 2007 December. Question number 9, part A2. Part A2. Part A is simple. It will explain the meaning of phase margin. That is the difference between W0 and C min. You can draw a diagram and show that. Second part is a question little tricky again. State 3 factors that determine its value. What they mean here is that why do you need a phase margin? That is the question. They are wording it this way. If I ask why do you need a fade margin, what is your answer? Why do you need a fade margin? What is the reason?
Multipath.
Okay, multipath interference could be one.
Absorption loss.
Absorption loss. Okay. Correct. Rain fading, atmospheric absorption, multipath. Those are the reasons those are the things which we can't exactly guess, isn't it? Since we can't exactly guess, we keep a safety margin. That is the reason. So those are the things they are asking here in a different way. If I ask, okay, why do you keep a fade margin? I think you know the answer. But if they ask like this, state 3 factors that determine the value of the fade margin. What are the factors? Those 3 again. So it's a way of asking the question in a difficult manner. So one is the effect of the rain. The rain effect is one factor which you can't predict. When the rain will come, how big is the rain, how big is the raindrop, you can't predict. Okay? Second, atmospheric absorption. Again, difficult to predict. Because wind power and so many things can come. And vegetation will be there. Due to rooftop saturation occur, it will be different from place to place. Okay? Then third one is multipath phase. Number of multipaths. Okay. Well, I think the difficulty there is the way they have asked. But anything can see what they are looking at. Sometimes it is the wording that will confuse you. Okay, I think it's time to stop. Okay. Hope you got most of the answers. I hope you took my advice of writing also before you going to go to the exam. Writing down as much as possible. When is the date for the radio?
June 2.
Second June. Tuesday. Right? Right. I also think we have covered almost everything except that you have to be aware of these tricky wordings, tricky diagrams kind of thing. Other than that, I think we have covered everything. So it's time to stop. And let me wish you a happy radio paper. Right? Radio, you know, is a tough subject. So what I would suggest is don't get excited. Start with the simple ones first. Try to score a few marks before you approach difficult ones. Those are basic techniques but very important there, otherwise people get excited when a paper seems to be difficult. And also lower your expectations. Before you go to the exam, some of us keep expecting the past paper questions, isn't it? And when you don't see past paper questions, you think it's a difficult one. Don't do that. Okay? So expect a difficult paper and go there. Expect a difficult paper and expect something which is not similar to past paper. Then you will not get excited because your expectation is there. But if you expect past paper kind of questions but they don't come, suddenly your confidence goes down, although the paper might be easier than past paper. Some situation it happens. Paper may be more simple than past papers, but you might think, okay, I prepared for these questions, but they are not real. Then you get upset. So that's also another mistake people do. Beware of those simple things and you should be okay. So regarding the start of our classes, next subject, those some of you have not done the other subjects, I think. For you it will be 4th of July. 4th of July, you have 1 month left. 4th of July we will start the other subject, and those who finish and decide to do CEI, it will be next week, next Saturday. Not here but at the real. And those who are wishing to do CEI, you can visit that website. I will update it with the syllabus. Visit that and I will update the syllabus. for CA. But don't visit today, right? Because CA part is not updated yet. But maybe other things you can find, but maybe by Wednesday I will update the CA syllabus content. Okay. All the best again, sir.